Hello everyone. So previously we had discussed on the topic line sweep algorithm, right? For the segment intersection basically. So today we'll be going with a circle line and circle intersection algorithm. Yeah. So let's see what the definition part say here. So for the circle line intersection, what it does, it determines where, if at all, a given straight line crosses the circle. Given straight line crosses the circle. For the circle intersection, it finds the intersection points if any between two circles. If there are any intersection points between any two circles, it will find it, right? So this is fine. So these are the two algorithms we'll be discussing in the same thing, right? So now let's move on with the explanation part. So the first thing, just listen to this carefully. The same thing will be implementing in the form of code. Yeah. So when a line usually represented as y equals mx plus c, right? So when a line is usually represented as y equals mx plus c here, which passes through the circle, we have individual straight line and a circle for the circle line, right? For the circle, we'll be having two circles, and all it does is it finds the intersection points if any this one intersection points is found between within the two circles, right? So these basically we have difference here, right? So when a line usually represented as first we'll be going with a circle line. When a line usually represented as y equals mx plus c passes through the circle, so this one x minus a whole square plus y minus b whole square equals r square. So substituting y gives a quadratic in x, right? So substituting y, what it gives a quadratic in x, right? So if the discriminant delta, if it is greater than 0, then two intersections are found actually. So see here, so this one equals 0, nothing but the tangent one intersection. So if this one delta equals 0, if delta less than 0, then no intersection, right? Then no intersection. Similarly, for two circles, we will subtract one from other, right? One from another, just to form a line. So then substitute back into one circle equation to get the intersection coordinates. So let's see the same thing, exact same thing. This one you have to know actually. This one you have to know, and this one as well, this one as well, through the circle, that whatever we have considered y equals mx plus c, and this one passes through the circle. So this one also we have to know, or substituting x, which gives the quadratic in x. So this is very important. The similarly to the this one circle intersection, we'll be going with these changes actually. We'll subtract one from another to form a line, then substitute back into the circle into one circle equation to get the intersection coordinate. So this is fine, I believe. Yeah, next let's do one thing. Now we have the this one, what do we call, circle line and I mean we have the idea on the circle line and the circle intersection all go. Let's start writing the algorithm. First let's go with the this one, what do we call, circle line intersection, right? So I'll just go with here def go with here. Let me type this one anyways. Circle line intersection. Yep. So within this, I need parameters a comma b, and I'll just go with r comma m comma c. Yep. So this is fine. These are the parameters that I need. First, we'll go with a circle. Actually, x minus a to the this one whole square plus y minus b whole square, that is equivalent to the r square, right? And line equals mx plus c, right? So that one we can represent on this way, a equals 1 plus here m square actually. I'll just make use of the exponentiation operator. This is fine. This is nothing but the coefficient of x square, right? So accordingly here, this one I said we have to know this at any cost, right? So we are going with a coefficient of x square here, right? So let me consider one more, this one variable b here. So this one will be 2 into m into, let me go with c minus b. It's actually c minus b. Yep, it's c minus b minus a. So what we are doing here, basically, this is the coefficient of x actually. So first line, the line number 16 is nothing but the coefficient of x square. So line number 17 is nothing but the coefficient of x. Then we have to go with a constant term, right? So I'll just go with another variable c. So this will be a to the power of 2, nothing but a square plus, so let me go with c minus b whole square, right? So c minus b whole square. So I'll just make use of the exponentiation operator here. 2 minus p square actually, right? Minus p square. Yep. So this is fine, I believe. So we are done with this part, man. We are done with the initialization part. Let's do one thing now. Now what shall we do? So we have to go with the discriminant as well. Accordingly with the explanation part, we have to go with the discriminant as well. So I'll just go with a variable name d. So let me go with b square here. B square minus 4 into a into c, right? 4 into a into c. So this is nothing but the discriminant. So the next part, let's go with a simple if condition, man. So we have to go with a no intersection when d is less than 0, right? So when d is equivalent to 0 or discriminant is equivalent to the 0, then we have, if suppose there is a tangent at this one tangent point, then we have to return the tangent point. These two things, the only two things that we have to go with here is one is when d less than 0 and another one is when d is equivalent to the 0. When d is less than 0, then there will be no intersection at all. So we just have to return empty array, right? So when d, the value of the d discriminant is equivalent to the 0, then we have to return the this one tangent point, right? Else we have to go with a two intersection points, three, sorry, right? So these three things for this, we can just write the simple if condition, right? So if d less than 0, then no intersection. I'll just return empty array. This is fine. The next step would be, I'll just go with the else if here. Else if d, if it is equivalent to the 0, then what shall I do? Let me assign x2 here minus b by I'll just go with 2 into a actually. Yeah, let me go with 2 into a. Also, let me assign y to m into x plus c, right? M into x plus c. Finally, we have to return the tangent point, right? So I'll just go with a return tangent point in the sense x comma y. So this one has to be x comma y. Very simple one. Then let's go with a final condition. Else what we have to do? We have to go with the two intersection points, or we have to return two intersection points basically. I'll just go with here square root of d. So I should have used this one imported math and did this. This is fine. Anyways, uh, I'll just go with here. Mm, this one. Let me import the math anyway. So I want to make use of the this one square root. So I'll just go with import math. Yeah, so this is fine. I'll just go with a math dot this one square root, right? Square root of determinant. So basically, I'll just pass the. Yep. So this is fine. Next, let me assign x1 to again. So I'll just go with a minus b here plus square root of determinant. So by 2 into a, by 2 into a. And next, let me go with the x2 equals minus b plus, or I'll just go with the minus of square root of d. So this is fine by, what shall I do? Let me go with 2 into a. Let me go with 2 into a. Yep, so this is fine. The third one, let me assign y1 to m into this one x1 plus c, right? X1 plus c, and also y2 to the m into x2 plus x2 plus c. What we need to return? So we have already discussed this one. We have to return the two intersection points, right? So this is simple. Return. So this has to be x1 comma y1. Yep, x1 comma y1, and also we'll be going with x2 comma y2, x2 comma y2, right? So this is fine, I believe. So this is it for the circle line intersection algorithm. Yeah. So next, let's move on with the this one circle circle intersection, right? So I'll just give here def. So let me copy the same thing here. So let me paste this one over here. So instead of these parameters, let me name here before that one, instead of the line, I'll just go with here circle circle. right? I'll just go with circle, circle. So this one 0, y0, r0, x1, y1, and r1. So this is fine. So within this function, first let's go with the dx, dy as well as the d. So dx, let me assign this one to the x1 minus x0. Yep. So next let's go with the dy equals y1 minus y0. And the final one, let's go with d equals math dot, I'll just go with hypot, this one, yeah, hypot. So I'll just go with dx comma dx comma dy. So this is fine. Next, let's go with a simple if condition one. So first we have to go with the no intersection one. All right, no intersection part. When we get the no intersection part, when d, small d, that is greater than r0 plus r1, or d less than this one, r0 minus r1. Right. So this one, I can just write it in this way. Let me make use of the simple if condition here. D greater than, I hope this works, man. Let's see. D greater than r0 plus r1 here, then, or let's go with when d less than absolute of r0 minus r1, right? So this is fine. Yep. So the no intersection, sorry, let me give colon here. So sorry, no intersection in the sense we have to return the empty array, right? So this is fine. Now we are left with this one. We call, we have to assign a, h, and other stuff, right? So let's move on with the same thing. Actually, let me copy paste this one. Just give me a second. So I'll just come here. Let me paste it over here. Yeah. So let me move this one over here. So this is fine now. Yeah, this is fine now. So let me, let's move on with the further things actually. Further, what we have to do, so we have to go with a tangent circle when h is equivalent to the 0, right? So when if h is equivalent to the value 0, then let me return this one, tangent circles, right? So this is similar, exactly similar to the same. So only thing is, so for the two circles, we'll subtract one from another to form a line, right? So then we'll substitute back into one circle equation itself to get the intersection coordinates. The same thing we have done here from here to here, which I didn't explain, right? So here, what we'll do, we will return actually, we have to return the tangent circles here. So we have went with a variable name xs1 and xs2, right? So I'll just pass xs1 comma this one ys1 actually, yeah, xs1 comma s1. So after going with the tangent circles, let's do one thing. Let's go with one more condition here. Let me go with else. Mm, let's go with a two intersection point. So I'll just go with return here. So this one is xs1 comma ys1. So this is also fine. xs2 comma ys. Yep. So this is fine. We just went with the two intersection points. Yeah, this is it for the all go. So this is it for the all go. So let's do one thing. We are done with both the algorithms in single shot. Actually, single line intersection as well as the sorry, circle line intersection as well as the circle circle intersection, right? So now let's do one thing. Let's go with the demo usage or the example usage. I'll just take the example usage or the demo usage from the Google as usual. Let's just give me a second. Yeah. See here, the circle center 0, comma 0. We have considered the circle center 0, comma 0 with the radius 5, right? Line equals y equals this one line y equals x plus 1. Yeah. So this is for the circle line, right? Circle center we are considering 0, comma 0 with radius 5, and the line we are going with y equals x plus 1. For the circle we are going with the center 0, comma 0 along with the radius 5. Same thing. So this one, another circle, we have went with the center 4, comma 0, comma radius, we are going with the radius 3 actually, right? So what is the output that we need to get actually accordingly with the algorithm that we have written? We have discussed the algorithm, we know the algorithm pretty much well. So accordingly with the algorithm, so for the first one, see here, we are going with this one, right? Sorry, one second, just give me a second here. Yeah, let's consider this one. Let's consider this one. Yeah, we are going with the circle line intersection 0, 0, 5, 1, 1, right? So radius 5 as well as the circle center 0, 0, we are going with. Yep. And y we are just going with the x plus 1. Yeah. So for this one, the output that we need to get here is 1.82, 2.82. Right. So 1.82, this one circle intersection point, circle line intersection points 1.82, 2.82 and minus 2.82, minus 1.82, right? So this one 1.82 accordingly with the calculation 1.82, 2.82, and another one we have to get actually minus 2.82, minus 1.82, right? Minus 1.82, right? So this is fine. So this is the output that we need to get. This is the output that we need to get for the first one. So for the second one, we have considered circle intersection here, right? So we are going with a double zero, nothing but the circle center, and this one a radius we are going with a 5, and for the second circle we are going with a center 4, 0 and radius 3, right? So for this output we need to get here as 3.2, 2.4. 3.2 with 2, 4, sorry, 2.4, and another one is 3.2, 3.2, minus 2.4, minus, sorry, minus 2.4. So this is the output that we need to get actually. Yep. So this is fine, I believe. So let's do one thing. Here, first one, for the circle line intersection, for the circle line intersection, the line y equals x plus 1. So the for the first one, this one actually, for the line y equals x plus 1, whatever we have considered. So this cuts the circle x square plus y square actually, x square plus y square. So for the line, this one, we are considering about this one, this example, right? For the circle line. So the output that we need to get here is 1.82, 2.82, minus 2.82, minus 1.8, minus 1.82. So why we have to get that output? See, for the line y equals x plus 1, what we are going with, it cuts the circle x square plus y square. X square plus y square in the sense it will be 25, y square plus y square, which will lead to actually 25, right? Sorry, x square plus y square is 5 square, nothing but the 25 actually, right? So this is fine, man. Next actually it's plus 3 square, right? Yeah. Yep. Anyways, this one, x square plus y square is 25 at 2 points actually. At 2 points, that is almost equivalent to 1.82, 2.82, and minus 2.82 to minus this one minus 1.82. Right. For the second one, listen to this carefully. For the circle intersection, the first circle we have center 0, 0, radius 5, and the second center 4, 0 and radius 3 intersect at 2 points. Intersect at 2 points. You can just draw the graph and see it will be 3.2 at 2, 4 and 3.2 minus 2, 4. Right. So this one we have to get this one as the output. Let's check the same. As we are completely aware of the algorithm and the computation part, let's do one thing. I'll just give you a control J, Python followed by the this one. What do we call? File name dot py. Right. So we have what error we have. Name P is not defined. Line number 20. Okay. Hmm. What we are going with actually here? C minus B. So yeah, we are going with the R here, right? So I have given P here. Yeah, this is fine, man. So let me give clear screen here. Let me this one. Yeah. See here the output for the circle line intersection we are getting. Three. So this 1 second. So let's see. We just have to use the line intercept, I believe. So I'll just come here. Just give me a second here. So this one here, the line number 21, this one basically, this is fine. In the line number 29, we have to go with the this one, small c, the line intercept c. And also the same thing. See, we have to make use of it here and here as well, I believe. So now we have to get the correct output. Let's see, as discussed. Yeah, still we are not getting the correct output. So I think this power operation is breaking actually. I have left the space here. So let me check this one. I don't know. It be this itself is causing the problem, I think. I don't know. I think so. I'll just give clear screen. Enter. Oh man, this was not the thing actually. Uh, this is fine. One second. So actually what we have done here is this one. Uh, so the output that I explained so before this one 1.82 to 2.8 sorry 1.82 comma 2.82 actually. So that one it actually comes from the smaller circle, right? Smaller circle, right? So we shouldn't be considering that one actually. So we have considered the point 0 comma 0 comma 5 and 4 comma 0 comma 3 I think. So for this one actually we have to get the output this itself 3 comma 0 4 comma 0 minus 4 to 3 and 4 comma 0 minus 3 comma 0 4 to 3. So this is the correct output actually, whatever the output that we are getting. I got confused, sorry. So instead I took the smaller circle one, right? Sorry. Yep. So we are getting the desired output. We are getting the desired output. Let's do one thing. As we are done with the algorithm, let's quickly discuss the summary part. So we are getting the desired output. Let's move on with the summary part. As we are done with the circles line and circle circle intersection all go, let's move on with the summary part. So here circle line intersection, what it does, it substitutes line into circle equation, right? Basically solve will be solving quadratic, right? So this is the first one. Second one is circle circle intersection. So basically it uses the geometric relations. It primarily uses the geometric relations and distance formula to find the intersection and distance formula to find the intersection. It handles tangent comma intersecting and disjoint causes cleanly. And the final one is time complexity is big of 1 for both. It's pure geometry computation. See here, the time complexity is big of 1 for both. It's pure geometry computation, right? So this is fine, I believe. Yep. So this is it. So next, what we'll be doing, we'll be discussing the last algorithm and the geometry-based algorithms, nothing but Voronoi diagrams or Delaunay triangulation, right? So for now, this is it. Thanks for watching, guys.